We'll call this harder sums and differences of cubes. So let's do a quick refresh before we get into the cubes. There's what's going to happen today to you is over and over again, you're going to find that you'll hear me use this expression now a lot, that the offspring produce then their own offspring. So what you've grown accustomed to in all these factoring problems is that you do one line of work and you're done. Like you might pull out a GCF and then factor, but you still, when you're done, it's effectively one step. What's going to happen today is those offspring that you create. So like you have this master problem like x cubed minus 27, and it produces x minus 3 times x squared plus 3x plus 9, blah, blah, blah. And those are your offspring. What happens today is those offspring then spawn their own offspring. So you factor something down, and then you can factor part of it yet again. So before we get started, we have to do a quick review of things like this, this, this. These are Algebra 1 topics, but they're going to be all over the place. So I thought, let's get this out of the way real quick so that when we see them in today's lesson, then we don't have to, we're not going to panic. Do you guys remember what these are called? They have a name. It's a difference of two squares. Very good. So a difference of two squares is a really special sort of unique situation. And the reason why we can factor differences of squares is because, well, when you factor, I don't know how I was going to finish that thought, but if you factor something like x squared minus 4, it factors beautifully into an x with a plus 2 and an x with a minus 2. And the reason it works so beautifully like that is because the minus in the back, it green lights us to use one plus sign and one minus sign. And it's the beauty of the plus and the minus that makes the magic happen. So if you think about a difference of two squares, there's like a 0x in the middle that you're trying to murder off. And if you study what you have here, then you go, oh, that makes sense because my blue combo is 2x and my green combo is negative 2x. And that's why there's no x in the middle, right? So that's a real simple algebra one-y kind of, it's a quadratic factoring, but it's a special one called a difference of two squares. How about that next one? What would he factor into? 9 minus 16x squared. What would he be? Careful, you can't reverse the order because it's subtraction. So keep everything literally left to right. So what you want to try again? Perfection. So the way by we, I mean like Alyssa, the way we're arriving at this is we're just simply taking the square roots of the terms. You kind of attack it mentally the same way you would attack cubes, like a and b are just cube roots. So what we're looking for here are just square roots. The square root of 9 is obviously 3. So we place a 3 here and here because 3 times 3, makes 9. And then the square root of 16x squared is 4x. And you place one of those here and one of those here. And again, the beauty of it is that if you put one that has a plus and one that has a minus, these two things cancel out. Not those two things, apologies. These two things cancel out, the green and the yellow, to make nothing in the middle. You still with me? How about the third one? Someone else, please. What would that third one factor into, Brady? Good job. Your ability to recognize these is really important because they're what's going to pop out. What's going to happen today when we start doing our examples is one of the offspring might be its own difference of two squares. And so whereas before we do our short set, long set, call it a day, now we're going to study short set and we're going to go, hey, short set, are you one of these? Can I take you another level down? Right. And my final thought before we press on is, what does this factor down into? It's not factorable. So what happens with cubes is you get in the mindset that with cubes, you can do plus and you can do minus because we have a formula for each. But squares produce, we run into a quandary. If I was going to factor this down the way you might think you want to, like this, why does that fail? Because then this would need to be a -4. Like you can't avoid, this is inevitable that no matter how many combinations of signs you try, you're going to fail. The combo you want to try first is the plus minus to make the middle disappear, but that's logistically impossible because then you get the negative in the back, right? And then if you try saying, well, maybe I'll make the signs the same, well, now the whole thing's gone to poo because if you put like a minus in both of them, now you're going to get x squared minus 4x plus 4. And if you try putting a plus in both of them, then you get plus 4x plus 4. So you're really screwed. So I need you to be aware of the fact that you can factor differences of two squares, but you cannot factor sums of two squares. That'll become one of our biggest mental roadblocks in the next couple of days. With cubes, if I gave you this problem, you can factor it into short set, long set. If I gave you this problem, you can factor it into short set, long set. Cubes have that ability. Squares do not. With squares, we have to have a minus sign to enable the magic that we want to happen. Clear? So differences of two squares, you can factor sums, leave it alone. It's done. All right, so let's run through some examples. I've got 6 of them. I don't know if we'll need all 6. Never know. Play it by ear. So let's do x to the 6th minus 64, y to the 6th. Having done yesterday's delta math, I'm sure you're not frightened by the fact that there's variables on both terms. So we're not scared. We recognize first off that there is no GCF. I don't know that any of today's problems are going to have GCFs, just for the record. I think this next delta math assignment is just a foray like into the harder problems. And then I'll start burying these even in GCFs on like Monday or maybe later tomorrow. So there's no GCF. So it's time for me to figure out, what I do. What's A? It's always a tough question the first time. The answer to my question, let me ask my question a different way, because it's always hard the first time. What would you have to cube to make x to the 6th? X squared. Good. That's called a cube root. And you may think, well, that's just crazy talk. But we never really think of it like this because we haven't had to until this point. But now we have to be quite literal about the fact that when I look for A, what I'm actually doing is taking the cube root of x to the 6th. And as you know from previous lessons that we've done, to get that exponent, you just do 6 divided by 3. So that's kind of the cat out of the bag. There's the big secret. If it has an exponent, divide it by 3, and you'll get the cube root exponent. So there's my A value. What's my B value going to be? Excellent work. Top notch, 4y squared. And you attack that in pieces. The cube root of the 64 was 4. The cube root of the y to the 6th was y squared. So that's a huge part of the battle. It always is can I figure out who A and B are? Because now the next part of this, I think, is pretty robotic. There's not a whole lot of do you or don't you get it. It's just a matter now of saying, okay, short set, long set, I'm going in. The formula doesn't change. Even as things start to look fancier, the formula just doesn't change. And so what goes in the short set? Top notch. A minus B. Always the same. I've actually had students in the past that don't write those down, the things I just circled in red, and invariably they're always the ones that struggle with this. So you can take it or leave it, but writing down who A is, like explicitly writing it down, and writing down A, writing down B, Huge, because then it's just dropping them in, man. So what goes first in long set? X to the fourth. Very good. Because that's where a squared would go. And of course, x squared squared is x to the 2 times 2. What's going to go in the middle? Plus 4x squared y squared, top notch. And who's going to go at the back? Plus 16y to the fourth. So the reason I started class today the way I did had nothing to do with what we've done so far. What we've done so far is pretty basic, right? But why I started class that way is because our job now today is to recognize that we're not done. Like if we pat ourselves on the back and type this into Delta Math, it's going to ding us. It's going to say, sorry, your answer is incorrect. You have one attempt remaining. And so, dang it, what did I, well, here's what I did wrong. I missed it. That thing I just underlined in blue is his own factorable expression. You would recognize that, I hope now, as a difference of two squares. And that becomes your job now, is to start thinking multi-layered, like when I produce an offspring, can I look at that offspring and now say, they're going to be like grandkids, right? And so if you think about that x squared minus 4y squared correctly, what does he factor into? Yeah, in either order, x plus 2y and x minus 2y, as long as you have one of each. And again, where those come from are the square roots now of the pieces of the difference of two squares, right? And then the long set is not going to be your concern. Just like before, you're not going to try to factor the long set down. Your offspring are always going to come from the short set. Follow? It's not hard, is it? You just have to be cognizant of the fact that one step oftentimes isn't going to be enough. Every problem isn't going to be multi-leveled. Like I have a couple examples sprinkled in here where you have to look and not just assume that it's multi-level factoring, right? We got to be smart about what is the offspring? Is it factorable? So let's go again. Let's do 27, x to the sixth minus 8, y to the sixth. And I changed all my variables for today's notes to x's and y's. In Delta, you'll see a's and f's and m's and p's, and so it doesn't matter. But I just like x's and y's, so I did all my notes that way today. No GCF. So it's time to do A and it's time to do B. So from this term, what is A? Nice job. You guys got that quickly. And then what is B? 2y squared. So again, I have a formula for this. I know now that I can just airdrop these things right into my long or short set, long set formula. So my short set is here. My long set is here. What's short set going to look like? What's long set going to be? And again, it's the onus is on me now to look and say, can I go further? So the temptation here that, well, it's not, it's your job is to look at this and say, are you factorable? Is that a difference of two squares? It is not. And we think that it is because we see an x squared and we see a minus y squared. But who's breaking the deal is this pesky 3 and the 2. 3 and 2 are not square rootable numbers, so they prevent this from being a difference of two squares. Even if one of them was a square rootable number, so like even if I got like 9x squared minus 5, I still cannot factor that because the 5 is like the blocker. The 5 saying, can't square root me, we're not a difference of squares, stop here. So in a case like this, this would be your final answer. That becomes a tough spot. Is like, how do I know when I go further or when I stop? And that's what I guess what I'm trying to tell you is just look at the short set and recognize if it can go further. Do you have a question?
Oh, so what we need to look for if both numbers or every bullet if there's a
Right. Difference of two squares. Right. Yep. And eventually I'm going to scaffold this up, but it doesn't happen Actually, it happens in the next example. How ironic. You're actually going to see, I'll let you see it yourself. How about this? I'll just put it up here. This looks like such an innocent little problem. And honestly, it's not that bad if you've been doing all your work to this point. But what is this? It's important to me that you can name things. Sometimes I don't care about vocab, but when I say, what is this? I want you to be able to say, what is it? Sum of cubes. And I want you to start practicing answering those questions. It's a difference of cubes. It's a sum of cubes. It's a difference of squares. Us being able to say that to each other is going to make us better. And so this is a sum of cubes, right? Okay. It's an interesting problem. What's A? X to the third. Interesting. Yes. And again, as long as you know the rule that when I'm cube rooting, I just divide the power by 3, right? What's B? Okay, so watch out. So here we go. We're going to plug these A and B values into short set, long set, and we're off to the races. There's short set, there's long set. What's going to go in shorty? Nice. What about long set? Mm, mm. I haven't heard anyone say the correct exponent yet. X to the what? Nope. 6. When you take your A value, which is X to the third, and you square it, which is what we always do, 3 times 2 is 6. You guys, you had it surrounded. Some of you did 3 plus 2 to get 5, and some of you did 3 squared to get 9. But at the end of the day, remember, squaring means to double your exponent. So we get X to the 6th. Now I'm ready for you. Minus what? Plus 1. And again, long set, bless you, long set is not my concern. But now I look at the offspring and it's on me. What is that? What is it? It's a sum of cubes. And I know now that if it were squares, I couldn't factor it because there's a plus. But I also know that with cubes, I can do plus or minus, right? So if I recognize short set as his own now sum of cubes, he spawns his own little problem. So you take a sum of cubes and one of his offspring can become its own sum of cubes. So when you look at short set, just the part I have underlined in blue, I now need to identify a new A value. What is it? And a new B value. What is it? Nice. So what's happening now is just the thing I have underlined in blue is going to spawn now his own short set, long set, and then I have to copy down the old long set like this. Offspring producing offspring over and over again. So now that I know my new A and B values, what will my short set be on the new X plus 1? And this is your final answer. Okay. So far, so good. Okay. Let's keep going. This has notoriously been a difficult section for people, but you guys all year have proven to me that things that in the past have been difficult for my students, you guys seem to generally be handling quite well. So, yeah.
Will the second short set?
It can. If we start with, like, if you were to just go home tonight, which I certainly don't expect you to do, but if you went home tonight and wrote an even bigger version of this problem, like X to the 18th plus 1, you could break it down and then break it down. I mean, you might find yourself doing 3 layers of factoring depending on how much there is at the beginning, right? I don't think it's going to happen to you today. I think the most layers you'll have today is 2, but it could happen, right? And you'd be prepared for that because you just very patiently, let me color code this for you. You very patiently identify, can that offspring produce more offspring. So you see that blue became blue, right? But it can keep going. There comes a point though where it's almost just comically annoying, you know what I mean? Yeah. Let's go again. Please identify for today everything as a sum or a difference of cubes. For the record, this actually is a difference of two squares, but I don't want to attack it that way in step one because it alters um, stuff we don't want to talk about for step two. And so identify all of your problems today originally as sums or differences of cubes. So if we recognize this as a difference of cubes, what's A? What's B? Nice. And so we're ready with A and B. We're armed and dangerous, and we're ready to show short set, long set. This, I say, having worked for a couple days, done some assignments, this ought to be old hat for you guys. What's short set going to look like? No. Yeah, remember, short set will mimic the original problem, and then it's all pluses from here. And then what? Yeah. So long set, you just kind of got to wash your hands of that, but then your focus always becomes short set. And what do you recognize about short set? What is he called? Difference of squares. Good. And that's what we started class with today is I can only do squares if there's a minus in between them, and there is a minus in between them. So I'm ready now to break it down. And this is not a short set, long set factoring. This is a plus minus, I think, simple factoring. So the first thing I like to do before I forget is copy down my original long set. It's annoying, but it takes like 4 seconds, whatever. So how are we going to factor down 1 minus x squared? 1 minus x. 1 plus x, 1 minus x, right? It's just that typical plus minus pattern. So we have a 1 plus x, and we have a 1 minus x, and that whoop, is your final answer.
Does the order of the numbers in the
You mean, could you put x minus 1? No. I was telling Alyssa this earlier. Subtraction is not negotiable. Like, we don't take and just suddenly think of it as x to the 6th minus 1 because we want to. Now, the only one that would be negotiable would be like if for some creepy reason you insisted on writing 1 plus x as x plus 1, you could, because plus gives no you know what. And we could also, if you wanted to, screw around with this one, but I just don't see the point. Basically, leave everything in the order that it comes to you. Good? Right. Still feeling good? Is this easy? Moderately? What's this one? So what do we do? Nope. So what do we do? Nothing. It's done. I wanted to throw one of these in here to try to catch you, to go back to something I said. I'm not trying to be mean, but that was a trap. And earlier in the lesson, I told you very explicitly that sums of squares cannot be factored. And the moment those words fall from your lips and you say, what is this? It's a sum of squares. Then you say, game over. This is a prime polynomial. It cannot be factored. Clear? If it were cubes, we could do our cute little short set, long set. If it were a minus in the middle, we could do our cute little plus minus pattern thing. But when it's a square plus a square, game over. Watch out for that. I have one more actual example, not a trick question this time. So, and then it's work time. It's a difference of cubes. So my mindset is I best figure out quick. I better get on figuring out what A is and what B is. So what is A? Nice. What's B? Nice. So now we're ready. We're ready to hop on in and fire up the old short set, long set. Pull that starter. Let's get going. What goes in shorty? Nope. And what goes in long set? Done? Not done? Why not done? Because that is two squares with a minus between them, aka a difference of two squares. And differences of squares can / need to be factored further. So long set is just going to get copied down. Like you could just bring it straight down. Again, it's annoying. Sorry, not sorry. But short set is going to produce his own little cute plus minus offspring. What are they going to be? Done? Do you have any questions about that? Your questions will really mostly pop up here in a minute when we pop up Delta and get going on our assignments. But this assignment is on Delta Math. It's assignment number 26, and I had it set to assign itself. It's been up for like 15 minutes, and I say it's due. I think I have the due date as like Monday morning or Sunday night, something like that. So you've got some time to get it done. No, tomorrow we'll work on it, yes, but there'll also be more tomorrow, like more work, probably a paper worksheet tomorrow. Okay. All right, cool.